Okay, hello, good morning or afternoon, depending on when you're watching this presentation. We're going to talk briefly about potentiometers and rheostats. We'll naturally be covering these thoroughly in class, but it's really important that you read through all the tutorials and resources online that I've made for you, because that really has all the finer details. We're just going to go through an overview today. We're not going to be doing any math. And that's already covered in the handout, so I will leave you to go through those on your own. Okay, so a potentiometer, which is the physical part or device. So this is what they look like, and they do come in different forms, but we're just going to limit ourselves to this particular packaging style because that's the ones that we have in our kits. Okay, sorry the pictures out of focus. It was a little kind of hard to hold everything together, but anyway, so you can see the device has 3 leads, and this is sort of a side view. Has the part code on the top, and this is a 502, which is a 5K pot. Okay, there's how you read it. This would be for 100 ohm, 10K, and so on. So it takes some time. It's also in the other handouts to familiarize yourself with reading the resistance code off the device. Anyway, on the bottom you can see you have 3 leads. They're in a triangle shape, and at the top is an adjustment screw. So if you look from the bottom, and sometimes we get these, it doesn't make any difference. It works exactly the same way. We have three leads like that. Okay, so we have 2 outside leads, and the center lead is the wiper. That's the metal part that slides along the resistive element, and the wiper is attached to the screw. So when you turn the adjustment screw, then you're moving the wiper across the resistance inside, and that changes the resistance. Okay, so the wiper in either this configuration or this configuration, it's always in the center. Okay, as a rheostat. Now the potentiometer, that's the name of the device. It can be used as a potentiometer, which is variable voltage, or as a rheostat, which is a variable resistance. Again, it's the same physical device. And so what you want to do is you want to jumper one of the outside terminals. So I've arbitrarily, these are not marked on the device, so don't look for these markings. But the 2 outside leads, for the sake of the presentation, I'm calling lead terminals 1 and 3, and then the wiper is always in the center. Okay, so 1, 3, wiper in the center. So either through an external jumper, connect the wiper to pin 3, or the wiper to pin 1. So basically you jumper the wiper to one, but not both, of the outside terminals. Doesn't matter which. Nope. If you jumper it one way, you'll get max resistance when you turn it clockwise. If you jumper it the other way, you'll get max resistance when you turn it counterclockwise. It works exactly the same, so it makes no difference. Okay, again, more information on the handouts, but this is the easiest way I know how to explain this. So inside there's a resistive element, and this is obviously the wiper. Okay, and we'll just arbitrarily call the resistance, this is internal, from the wiper to pin 1 as resistance A, and the wiper to pin 3 as resistance B. So can you visualize that as we move the wiper upwards, the portion of the resistive element between 1 and 2 goes down? So as you move the way it's jumpered, as you move the wiper up, that means then that the resistance of RA goes down, and therefore the resistance RB from the wiper to pin 3 must go up. Okay, so how you get variable resistance is current comes down like this. Okay, electrons are lazy, they'll take the path of least resistance, so they will bypass around the wiper, right, and then on out. So the portion of the element, and in this case the wiper set about the midpoint, the portion of the element that is bypassed or shorted out by the resistance, then is effectively 0 ohms. So if this had a 1,000 ohms nominal, so that'd be a part code of 102, and if the wiper was in the center of the element at 50%, the effective resistance would be equal to exactly half, or 500 ohms. Let's call that actual or effective. Okay, so yeah, it's a little messy, but as you move the wiper up and down across the element, the resistance changes because either a greater or a smaller portion of the element is shorted out, and effectively making that portion of the element 0. Okay, do have a look at the handouts. It's better explained there with actual numbers, but in essence that's what's going on. Okay, we're using the potentiometer as a potentiometer. The potentiometer gives us variable voltage, and then once again the rheostat. I should put this on here earlier, I'm sorry. Variable resistance. Okay. All right. So notice that the wiper is the same physical device, but the wiper is not jumpered. So pin 2, I'll draw a line here. Okay. So pin 2 is the wiper. Again, it's simply connecting to a voltmeter. In real life, that would go to another electronic circuit, but for our purposes, just a voltmeter. As you move the wiper up and down across the element, then the voltage between the wiper and the ground, the common, changes. Variable voltage. Okay, so same idea. Okay, so if we were to monitor the voltage here, so this would be our voltmeter, which I'm just calling voltage between pin 2 and pin 3. As we move the wiper up, then the voltage here will go up. So if we move this wiper upwards like this, then this voltage here will increase because we're measuring across a larger portion of the element. If we don't, I don't want to change color here. Let's go with green, something different. As you move the wiper down, then this voltage here goes down because it's measuring across a smaller portion of the element. Okay, so right, so if you have the wiper up here, right, then or if you redraw like this, okay, and you move the wiper down here, assuming it's connected to the same power source. Okay, I'm not going to worry about what that is right now. Battery like that. Battery like that. That means then that with the wiper here, this voltage here will be larger than this voltage here, because the wiper here, there's more of a span between the wiper and the circuit negative as opposed to here. Okay, so larger voltage here, smaller voltage there, I know it's confusing, but read the handouts. There's examples there, and we'll do some examples in class. But simply put, that's what's going on. Okay, great. That's about it. Thanks, and we'll catch you next time. Cheers.